Good. Good, good, good. Okay, so we are. Oh, I guess I. Ay, ay, ay. We're talking about routing, right? All right, so what is the job of a router, Adiel? Yeah, to find the best path to send packets, right? And how does it do that, Umberto? Yeah, so it. Yeah, I would agree. Like they talk to other routers and share information, right? And then there's some specific like algorithms or numerology that determines the routes that go into the route table. What is that based on, Jocelyn? What's the question? So how are the routes determined that go into the route table? So we know it's the best routes. We know that the routers share information, right? And then with the best routes and the sharing information, it determines what routes go into the route table, which are the best routes. So what's that? How is that determined? How is it determined what goes into the routing table? Well, if the best routes go into the route table, how are the best routes determined? The router looks at what?
No idea.
Chase.
The administrative distance?
Yeah, it's going to look at the administrative distance, right? And when there's multiple routes in the route table, what is the router looking at and comparing to determine which of those routes? It's going to pick the lowest administrative distance, right? But what if there's 3 routes that all have a low administrative distance? What's it comparing? The longest match, the longest bit match, right? The longest bit match. So the router is doing all this work, right? And there's some algorithms that go into all of this, and there's administrative distance, and EIGRP runs different types of algorithms. OSPF runs different algorithms. And so someone said the lower administrative distance is better, right? Okay, so what is a directly connected administrative distance? 0. What about a static route? 1. How about OSPF? 110. ISIS? 115. RIP?
120.
EIGRP? Internal?
90.
External?
170.
Yes. BGP? Internal?
200.
External? 5. 20? 20. Which one's 5? EIGRP summary routes? Okay, that sounds right. All right. Good, so we're off to a good start. So, like, when we're leaving layer 2, right? So we talked about STP, we talked about Ether channel, PAGP, LACP, port security, right? BPDUs, so that was all layer 2. So with module 14, 15, and 16, we basically are moving to layer 3, right? And so we're moving from talking to the LAN to now being able to move outside of our local area network, right? And so let's review the OSI model. Who can, raise your hand, who can give me the OSI model? Adiel. Exactly. Do we all agree? Yeah. Okay. And what are the 2 sublayers of the data link layer, Jocelyn?
Electrical link and media access.
Yeah, media access control, LLC and the MAC sublayer, right? Okay. And okay, so how the router works, the router is sending and receiving messages, just like what Umberto said, right? These guys, they're all talking to each other. So routers keep track of 3 different tables. So we talked about the route table, and what routes go into the route table? The best routes. And what are the other 2 types of routing tables that the routers keep track of? Yep. Neighbor table. And this might not have been in the reading, but we've talked about it, right? This might not have been in the reading. So the IP route table, the topology table. So it keeps track of those 3 things. And with that information from those route tables, it can run the algorithms that it needs to run in order to put the best routes into the IP route table, right? So, and if a router, if a link goes down or an interface or something goes down, well, then they can all talk to each other and recalculate that. So depending upon the routing protocol, they'll keep track of different routers that are their neighbors. plus the overall topology, and that's how they are able to recalculate, is they've got these other tables. So they're like, oh, well, this link went down. Let me check my neighbor table and see who else might be next to me that I could use instead of the route that I was using. Okay, let's see. So they will exchange information so they can learn about remote networks, because this is directly connected, so that's easy for them to learn about each other. And now this router will be able to share information about its other directly connected network with this one. That's a remote network, right? So this allows this big communication so that they can create these routes. And then they're going to find the best routes, and they're going to put the best routes into the routing table. So again, the best route on this router might be different than the best route on this table based on the different link speeds, protocols, ports, things like that, okay? So if we look at this, right, if we think about the way that a router thinks and its logic, okay? So a packet is going to go into the interface, and then what does it do next? What happens once that hits the interface? The router examines the packet, right? It de-encapsulates it, okay? And then what does it do? Now that it's de-encapsulated it, it can look and see the what? The IP address of the what, though? The destination. It's actually looking for the destination. So it looks at the destination, so now what does it do?
If it's the local, directly connected,
Okay.
you send the message.
Even before that, so what does it have to do now that it knows the destination IP address? That's a MAC address.
You look the out.
Nope, it doesn't need to do ARP. So it's there, it's on the interface, it knows what the destination is, so now it's going to do what? It's going to look at the what?
The routing table.
It looks at the route table, right? So the traffic enters the router on the inbound interface, it looks to see what the destination is, and then it checks its route table to see, do I have a destination route in my IP route table, okay? So if it sees the destination in there, then what does it do? It sends it out the outbound interface, right? So in this scenario, let's say it's looking for 192.168.0.10. It'll say, oh, okay, well, you're going to go out serial 000, and it sends it to serial 000, okay? So the router uses a route table to determine how to reach the destination network, right? And now it's going to send it out the outbound interface to whatever the destination is. That might be a next hop. That might be the actual destination. It's hard to tell. So when the inbound packet matches the route statement, it forwards it out the exit interface, right? Think of it like mail. The mail comes into the post office says, oh, Florida, I got to put it in this bin, right? And then it gets shipped out, okay? So let's see. What happens if there's no route in the route table? So our packet is at the inbound interface. It looks at the what? It looks at the route table, okay? So now, what happens if it doesn't see anything in the route table? It doesn't see the destination. What does it look for next? It looks for a default route, right? It's like, well, I don't know how to get there exactly, but is there a default route? Now, what's the purpose of the default route? It is the last resort, so what's the purpose of the last resort? Yeah, exactly. So maybe I don't know how to get it there, But maybe I can send it to the next router, and that router might have a route to the destination, right? So we're going to try to get it there if we can get it there, okay? So what it does, right, it looks at the route table. If an inbound packet doesn't match the route statement, it will look for the default static route, and then it will send it out the exit interface. In this case, it says it's directly connected to 001, so it would send it out whatever interface is 001. And typically, the default route or the gateway of last resort would be the what? What do we normally set that to be? Yeah, our ISP. Because we're going to assume that the ISP probably has giant route tables, which it does. It has a gazillion routes in its route table. Not only that, let's say we're on Cox Communications right here, and I'm sending a packet out, and it just so happens that the packet belongs, its destination is Verizon. So my personal route table might not have that. It's possible I kick it to Cox, and even Cox doesn't. But they would be able to tell based on the destination IP address, oh, this is probably a Verizon packet. And then it would kick it to Verizon. So they also have a gateway of last resort. They might have multiple gateways of last resorts, depending upon what the prefix or what the IP address is. Sends it to CenturyLink, sends it to Verizon, sends it to AT&T. Okay? So, right, then it's going to go out the exit interface, and it makes it. Well, what if there is no gateway of last resort? Then what happens? Yeah, it just drops it, right? It's going to get thrown away. Poor packet. Doesn't have any place to go, and we're going to get a message back, right, that says, that gives us an error message, destination host unreachable, okay? So we are going to get a message back, and that packet will be dropped. Okay, so why a router? A router connects one network to another. It's responsible for routing of traffic between networks. A router determines the what kind of path, IL? The best path to the destination and forwards traffic to the next router. When a packet arrives on a router, what? The router uses its routing table, so it has to arrive at the what first? The interface. It arrives at the interface. That's when it starts to do its research, right? It's going to start doing its research as soon as it gets to the interface. Now, sometimes there's more than one good route because of what? What is that called when there might be more than one route to the same destination? Load balancing. Yeah, it's equal cost load balancing. So sometimes there'll be more than one route to the same destination. Now, occasionally it can even be equal matches, equal longest matches, in which case it'll just load balance. But sometimes you can have multiple routes to the same location, and you still have to look for the best match. So that's what we're going to look at next, right? So it's going to use the best match, okay? And the best match is when you have the most matching bits to your destination. So if I'm trying to get to 192.168.0.10, the route table is going to say, well, let me see, where do I have the most matching bits? That's the route that I'm going to pick because that's going to have the most trustworthiness, okay? So a minimum number of the far left matching bits. The subnet mask of the route in the routing table is used to determine the number that we look at. So we're going to do some of these together. We're going to practice that. The best match is the route in the routing table that has the most number of far left matching bits with the destination IPv4 address. The route with the greatest number of equivalent far left bits or the longest match, okay? The longest match. So again, it's going to look in here, it's going to find the longest match, and it will use that route to send. We're going to do an example. So here, if we're trying to get to 172.16.0.10, and I've got 3 different routes with different subnet masks, what we're doing is we're looking for similarities. We're looking for the most matching bits. So the way that you want to do this is you just want to bit it out. Now in this scenario, we've got 172, 172, 172, 172. So we don't really even need to bit out the first octet because we can see that they all match, right? Now the second octet, though, notice here this is a 12. So what octet do we need to be thinking about? The second octet. So I would go ahead and I would start my bitting in the second octet, right? And we just want to highlight how far these bits go. So if I'm trying to match 172, we got that. Now I'm trying to match 16. So does route 1 work? Would it work?
It would work. Yes.
It would work, right? Because 0001, that's 16, so this one would work. So now the router's going to say, well, okay, that one works, but is there a better one? Let me look and see if there's a better one. So now I have 18 different bits that I can look at. So I've got the 172, that matches. 16, that matches. 0, that matches. So does this one work?
Yes.
Yeah, so now this one's no longer a consideration. The first one's, because it's not as long, okay? Next, we're going to say, well, that's cool. I've got a match, 18 bits that match, but do I have any that match with even more? So now I'm going to look at my third route, which is I have 26 bits to work with. 172, does it match? 16, does it match? 0, does it match? Right? Now I can see here the 10, right? Those are all just host bits. I have another match. So now I have 26 bits that match. So again, if I compare 2 to 3, where do I have the most matching bits? 3, right? So now I'm not going to use this one. So this is the route. Even though multiple routes might be in my table, I'm going to pick the best route, the one with the most longest match, okay? So let's look into a couple of these, all right? So 172, 17, 90, 83. Here, and I'm going to hand this out. I've got a helper that you can use to bit these out. There's an example on the first page, and then the next page is they're blank. Okay? Again, this is one of those where you can do it in your head, that's awesome. But if not, just bit them out and you'll start to get fast at them and you won't need the helper anymore. All right. So let's take a look at this. If we were to bit out, so the 172, do I match? Do I match? Do I match? And how about even this one? I would match, right? Because the 0 means I don't care. I match everything, okay? So next we have 17, right? So does this one work? And this one? And this one? Yep, and we don't really even probably need to worry about this one. So next, let's think about the 90, okay? So how would I bit out 90? How do I bit out 90? 0, 1.
0.
That's 80, right? And then 88 there. Okay, so what do we notice here? That's as far as I'm going, right? So, does it work? Why doesn't it work? Because this doesn't match. 0 and 1 doesn't match. This doesn't work. These bits all have to match. Okay, so now I can do the same thing, right? Does this match? Does that match? Right? So, I mean, this is already not a match, right? How about 0? Same thing, right? Does it match? So this doesn't work. So now what? We have to use the default route. We have to use the default route. Because this one, none of these others match. So it's going to say, can I use this route? No. Can I use no? Nope. Oh, thank goodness I have a gateway of last resort. Does everybody understand that? Okay, so we've got to use the gateway of last resort. Okay, how about the next one? Okay, how about the next one?
Should I answer it or?
Here, well, let's do it. So 165, how do I write 165?
1, 0.
Do we agree? 160, right? Is that 160 plus 5, right? Yes? Is that 165? Okay. All right. So does this one work?
Yes.
It does, right? This one works. Okay, now let's do this one. 1, 0, 1, 0. What about this one?
No.
Right? It works until I get here. Doesn't work. Okay, how about 1, 0, 1, 0, 0, 1, 0? So does it match?
No.
Does it match?
No.
Yeah, it does.
0, 0. Oh, yes.
1 and 1, 0 and 0, 1 and 1. Here's where I stop. So what about this one? Okay, so now I'm going to compare this to this. Who has the longest match? The 19. The 19. Got it? Okay, so do the next one. So just don't call it out yet. Just figure it out. Okay. If you need to, just bid it out. So we've got 172, 17, 124. When you've got the answer, just pop your hand up so that I know. Jocelyn, do you have the answer? Okay, don't call it out, just let me know that you, because I want to give everyone a chance to figure it out. Got it, Adiel? Umberto? Okay, so 172 and 17, we've got that one covered, right? Okay, so let's do it. How do I write 124?
0.
Do I have to go any further? Does it match?
Yes.
What about here? Does it match? What about here? So, option 4, right? I got to take the gateway of last resort. Okay, do the next one. We got it? All right. Umberto, what have you got? Which one? Yeah, the 19, right? Because we know that 169, here's our 160, so we're good, right? So the 19 bits is our best match, okay? So then let's do the next one. Okay. Got it? Okay, what about this one, Jocelyn?
Option 2.
Option 2. Oh, no, it's option, is it option 2? Oh, I think it is option 2, right? Because 128 is on. That would be off, right? Yeah, so that's wrong. That should be down here. Because let's see, then if we do that, 120, 144, right? And then, yeah, so who knows what happened there. All right, how about the next one? 172, 193. Which one, Umberto? The first one? Yeah, right? Because if we do 193, it looks like that, right? So I have a match, but if I come down here, right, I don't have a match. So I would agree the first one is the first one. Okay, and then what about this one? 172, 17, 128.83. Well, let's see. So if we did 128, it matches this one, right? Okay, but then let's see. If I do 128, do I have more? I have more. So it looks to me, because see here, it doesn't work, right? So I think it's the 19. The 19. And what about 129? Same reason, right? The same reason, 129. Okay, so let's see. How can I fix this one? So we want this one to be, so I'm going to fix that. Okay, I know. Fix the matching. Okay, so let's do some Kahoots and brain teasers. Okay, so if you would go to, oops, what am I doing? All right, so go to your course modules. Okay, so in your course modules, scroll down to week 9, not the class activities, but your homework for week 9. So it's this week 9 homework. So below class activities. Okay. So it's under the spring break, right? March 20th. This is the homework, not class activities. Let's find this brain teaser that says week 9. Aren't we in week 9? We're in week 9. Week 9. Not class activities. Go lower. Go lower. Audio, did you find it? Thank you. So in the homework part. And let's do this brain teaser route, look up best path. Okay. Now, here's that same worksheet that I just handed out. Okay, if you ever need it, you can make copies. Okay. So let's do this first one together. What I have and what you have will be a little different. Okay, so let's do this first one together. All right, so 172, right? We're good on all those. Do we agree? Okay, now the 16, that looks good, but we've got to consider the 12, right? So if I do 16, it's going to look like this. And where do I stop in the second octet? Like where do I quit looking? At the which one? Right, so I quit looking right there, right? So I'm good. We're good. Then same goes with here, but I'm going to go a little bit further. 16, 17, 18. So I quit looking right there. Okay. But look, we've got to think about this 40, right? So how do I bid out 40 for this? Because I've got this, right? Then I need to do 0, 0, 32, right? So am I still okay? Right? Because I'm stopping right here if I'm comparing 18. So 0, 0. So which one's the best match? The second one. So far this one's better, right? That one works, but it's not as good. All right, now I got to do 172, 16, 0, 0, 0, right? So 0, 0, 0, 1, 0, 0, 0, 0. But how many bits am I looking at? 26. So I got to go all the way to here. So now what? I don't have a match anymore, right? As soon as I go into that third octet, I don't have a match anymore. So where does that put me? Right? The second one. Do we agree? Okay, and again, you can use that form to bid everything out. Let's do one more together. Let's see. Let's find one that's different. Oh, maybe they're all the same. Okay, we'll do this one. So we're trying to get this to 172.16.129.2, right? So let's see, let's start with the 16. So I'll bid this guy out. How do I do 129? There, and then 2. So we already know this one's a match, right? So that one works. 172.16.0, so if I go to the 18, 16, 17, 8, what about this one? It doesn't, right? Because I've got this. That looks good. But then it says 0. So there I've got a mismatch. That doesn't work. So now I know this one doesn't work, right? So here's an example where this really short little subnet mask is the best match. Does everybody see that? What?
You're going so fast. And then
Okay, you want me to slow down?
yes.
Okay. So let's slow down. So first thing is we're going to bid out where I'm trying to get. I'm trying to go here. And here are my route choices. This is what I have to choose from. So I need to find the one that matches the most bits. So if I look at this first route option, so here's this one. Okay, so let's look at this. And then 0, 0, 0, 0. So here's this route option, okay? And it says that I can look at 12 bits. So I know the 172 matches, that's this guy. So 8, 9, 10, 11, 12, so I can look up to this point. So I can see that 172 matches 172, and I can see that the 16 matches the 16. So this one will work. Now what I need to do is I need to see if there's one that has even more bits that will match the route. Okay, so again, I can see that the 172 matches. And then, so it tells me I'm going to be looking at 18 bits. So here's 8 plus another 8, that's 16, 17, 18. So now I'm going to compare all these bits. So the second octet matches. That's good. The second octet matches. But now I've got to look at these 2 bits. So I'm going to compare 0 to 1. Does it match? It doesn't. And it doesn't even matter what's after that. The minute I have a mismatch in my bits, it's no longer a match. Now, because the 18 doesn't work, I know the 26 won't work because that's even more bits, right? That's even more bits. So the one that's going to work is this one. Okay? Okay. All right, should we do one more? Okay, we'll do one more. Okay, let's do this one. So probably, again, let's just go ahead and we'll bid out everything. So I don't need to bid out the 172 because that matches everywhere. That matches. But let's do the 16. And then I'll do the 0. And then let's do the 2. Did we already do this one?
All of them are just 172, not 16, basically.
Okay. All right. So, how many bits do I look at for this one? 12. So that means I look up to this point. And does that match? It does. So this one works. Okay, now this one, I'm going to look at 18 bits. Okay, so I look at 8, 16, 17, 18. So I'm going to look up to this point. So does the second octet match? And then what about here to here? Okay, so this one works too. So far, which one would I be using out of these 2? Right, so this one's too short. Now we're going to look at this one. 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0. And how many bits am I looking at now? I got to look at 26. So 8. So the second octet, it matches. What about the third octet? Does it match 24 bits? Okay. 25, 26. I got to stop right here. So now I look, does this match? Does this match? Yeah. So now I know this one would work too. So I compare 26 to 18. Which one's longer? 26. So that's the answer. Okay? All right, so that's what this form can help you with. If you get a tough one, just bid it out. See, you bid out the destination IP address, and then you compare it and just draw a line. That's the easiest way. Like visually draw that line. So go ahead and work on this. If you get stuck on one, let me know. Hey, Marcus, did anybody come on Friday?
No, actually.
No? Okay.
No, not yet.
We'll try again.
Yeah. But to be honest, I kind of thought that would happen because most people finished up the assignment class anyway. At least I think.
That could be. When you're done, can you raise your hand so I know? Okay. Okay. How we doing? Getting it, Umberto? Good. If you're all done, work on another brain teaser or find something else that you could do. So a lot of brain teasers due this week. We're going to do some in class together. We're actually going to do that IP route one next, so you don't have to do that one because we'll do it in class. many do you have left, Jocelyn? Jocelyn, how many do you have left?
This one.
Just one, okay. Umberto, how about yours? Okay, good. All right. We're going to practice this a little bit more. Ready? Let's see. So look at the destination IP address and determine the best IP route. So same thing that we just kind of did. Okay, so let's look at this one together a little bit. So first of all, what kind of routes are these? Static routes. And then what specific kind of static route are they? So you can tell by looking at the format. So this is a what? A default static route, and specifically what kind of default static route? So you can tell by looking at this right here. So you've got next hop default static routes, and you have exit interface static routes. So is this an interface or an IP address? It's an IP address. So could this be an exit interface? It's not. It's an IP address. So that means that this is a next hop default static route, because that's an IP address. So the format of an IP route statement is the destination subnet mask, and then you either add the exit interface, which would make it a directly connected or exit interface default static route, or the next hop address, which would make it a next hop default static route, okay? So you've got a default static route, and then you can have a couple of different kinds of default static routes. All right, so this one, so first of all, if I'm trying to get to 172, right, so I come in on the interface, and I'm going to look at the what? Okay, and then I look at the what? The router looks at the what? Looks at the route table. And this is what it sees. It sees a default static route. It sees a route to 192, 168, 192, 192. So what, does it even see a 172 in its route table? It doesn't even see a 172, okay? So it can't be the 192, so none of the 192s work for this because it's trying to get to a 172.16.01. So if you don't even see the prefix, like that very beginning octet, then the next thing you got to do is you have to look for a what? A default static route, right? So that's what makes this one the right answer, is that this 192 can't do anything at all with a 172. There's no match, right? There's no match at all. So you don't even have a match after the first octet, and we need to be, we need to do at least 16, 24, or 28. So none of those match. Okay, let's do this one together. All right, so let's see, 192. All right, so let's just look at each of these together. So 192, does that match? And what about here? Yep, it does. And what about here? Okay. And then 168, right? So let's see, 255, 255. So we're looking at these first two full octets. So the 168, does that match? It does. And what about this one? It does, right? And what about this one? It does, okay. So far we've already got a match, right? We know that this one matches. Now what we have to do is we have to figure out if either of these bottom two gives us a better match. So I need to look at the third octet. I got to go into one more octet. Okay, so let's look at the third octet, and we got to see if we have any matches or mismatches, right, that mess us up, actually. Okay, so I don't even need to look any further on this one because I'm only looking at the first two octets. So now this one, how many octets do I look at? 255, 255, 255.0. I got to look at 3, okay? So the first octet is a match, and the second octet is a match. So if I compare the third octet of this route to the third octet of my destination, what happens? I've got a mismatch, right? Now the first, this matches, right? 0, 0, 0, those all match, but look at this very last positional value. I've got a 0, but I have a 1, right? So automatically I've got a what? I've got a mismatch, yeah, so this one won't work. Well, if this /24 doesn't work, I can assume that the /28 is also going to have the same problem, right? I'm going to get a mismatch as soon as I get to that one. So this one also does not work, okay? Does this address mean anything when it comes to determining the best path? No, it's just telling us where to get to next. That's just the next hop address. Okay, so we don't even need to consider that. All we care about is looking at the most matches, okay? So my advice is you bit out, you know, a couple of the octets so you can visually see it. That will help. Okay. So can you get out one of these blanks, everybody? Get a blank one of these. Okay. All right. So fill out the destination IP address, the 192.168.0.1. All right, so let's see. 192.168.0.1, right? And we don't really care about the prefix length. So let's just go ahead. We know how to bit this out easy enough, so let's just go ahead and bit it out. Okay, so bit that out on the sheet. I gotta look at this real quick and see what the. So let's see, we have 192.168.0.0.16, and I think it was a 24 and a 26. No, a 28. 28, okay. Okay. So let's see, our first route was a 192.168.0.0.16. Our second route was a 192.168.0.0.24 and a 192.168.0.0.28. So for this first route, how many bits can I compare? For the first route, how many bits can I compare to my destination?
16.
Yeah, just 16, right? Just 16. So I can do, let's see. Okay, so that means I'm going to compare octet 1 and octet 2, right? Do we agree? So this is Does this match? It does. Now what about octet number 2? Does that match? Yep. And do I even care about 3 and 4 at this point? I don't care about 3 and 4 because I can only look at 16 bits. So does this route work? Yes. Yeah.
Where come from those numbers? 16, 24, 28.
That's what's in the route table. On the route. See, look. When you look at the question, 192.168.00.255.255.00, that's a /16, right?
Oh, yeah.
And this one is 255.255.255.0, so that's a what? 255.255.24. Okay, and then 255.255.240, that's a 28, okay? So that tells us how many bits we can look at. Okay? All right, so now let's go ahead. How many bits can I look at for route number 2? 24. Okay, so again, let's fill out 24 bits. And it's 0, 0. So I'm looking at what? The first octet, and that's a match, right? What about the second octet? Okay, and then where do I have to stop looking? If I've got a 24, where do I have to stop? Right, so right here, right? So do I even care about these host bits? Don't care about them. So now, okay, 0, 0, is that a match? Right, we're looking to see if these are and everything matches in the third octet. So what does that tell me about this route statement? That's a match. Okay, so if I have 16 bits or 24 bits, which one is better? 24. So right now we're working with this one, right? So but I still have one more. I got to still see if this one. So let's see. We already know this, right? Okay, but now I'm going into the fourth octet, right? So it's my destination network here. Okay, so the first octet is good. The second octet, and then 24, 25, 26, 27, 28. So now I got to stop right here, right? Okay, so we've already determined that octet 1, octet 2, and octet 3 all match, correct? So now we're just going to look at these bits that I've got in the fourth octet. So 0, 0, does that match? 0, 0, 0, 0, 0, 0. Okay. Do I care about these? I don't care at all. Okay, so how many bits match route 3? 28. So now I'm like, okay, well, what's better? To match 24 bits or to match 28 bits? 28 bits. Okay, 28 bits. So that is why for this one, why this one works. Because there's more bits that match up to this destination. Now, what if this had been 192.168.0.16? Right, because then we would get a mismatch, right? It would look like this. And that would give us a mismatch. And it would be the second one, because the 24 bits would match. All right, let's do another one. Again, the cahoots are set, I think, to 90 seconds. So that's enough time to bid it out. Should be enough time to bid it out, okay? So the people that missed this, do you see why you missed it? Yeah? Okay, because I want to make sure you get this. This will be on the CCNA, I guarantee it. Oh, look, there's that same one we just talked about. Okay, yeah. See, the reason it didn't work this time, right, is because the first octet works, the second octet and the third octet, but this 240 means that we're looking, so if we look here, this looks like the fourth octet, right? And then here, the 240, so I have a mismatch right there. So that pushes me back to the 24 bits. That pushes me back to the 24 bits. That match, not, because as soon as I hit this mismatch within the allotted subnet mask, I'm out of the game. Okay, so let's go ahead and do the same thing. I want you to bid it out on the paper. Okay, so bid it out on the paper. 192, 168,026. Okay, so. So 192.168.0.26. Again, we don't care what the prefix is for the destination. And this one is a 16, right? A /16, /24, and a /28. Okay, so the first two octets are the same, right? So I'm not going to bid those out, okay? Because they're the same. So right off the bat, because these first two are the same, what does that tell me about this first route? Umberto, you're nodding your head. That means what? It's a route what? Yeah, it would work, right? Because this matches and this matches. So this one would work. All right, so now what we need to do is we need to figure out if there's a better route. So let's go ahead and look at octet 3 and octet 4, okay? So 0, 0, 0, 0, 0, 0. Let's look at 3 and 4. So 26. Okay. All right. So octet 1 works, octet 2 works. So now we need to see, does 3 match? Right? Because I'm looking at 24 bits, and here's 8 bits. Here's another, that makes it 16. This is 24 bits. Okay, so if I compare this 24 bits to this 24 bits, does it match? Jocelyn? It would match, right? This all matches. So now I have this route that would work and this route that would work. But why would I choose one over the other? Ariel? Because it's longer. So which one's longer? Route 2 is longer so far, right? Okay. But I still have one more route that I got to look at, right? I've got this one route where I need to look at how many bits? 28. I need to look at 28 bits. Okay. So the network address is 192.168.0.0. Okay. And so I'm comparing 28 bits. So 192, does that work? 168, does that match up to the destination? Okay, now what about octet 3? Does that match up to the destination? Yeah. Okay, so now I've got a few bits that I need to look at in octet 4 because I'm dealing with a 28. So this 0, does that match up? Yeah. What about this 0? Does that match up? And what about this 0? So far so good, but then look, I get a little problem. I compare the 28th bit to this 28th bit, and what happens? I have a what? I have a mismatch. So does route 3 work? No. So that puts me back at route 2. That puts me back at route 2, okay? So again, you've got to, if you're having trouble with this, you just have to bit them out and draw the line so that you're comparing them and seeing which ones really do match. Okay, so if you missed that one, do you see why you missed it? Okay. Because we only had one right one there. Let's see. Two right. Okay, so if we look at this one, everyone got it pretty close, right? So the 192, right, that's good everywhere, we agree, right? The 192 is good everywhere? Okay, So then we're going to look at the 170 because all of these we're looking at the second octet, right? 255, 255, and then 255, 255, 255. So at least we need the second octet to match. So I can look and see, I can say this 170, does that match 168 in the second octet? So right away it's a what? Yeah, right away this is a mismatch in the second octet. So this one won't work because remember we're looking at all 16 bits. We have to match all 16 bits. Well, the same thing's going to happen here, right? Because already the second octet doesn't match the 170. And here I would have to match 24 bits, but I can't even match 16. Right? And same goes with that one. So that pushes us to the default static route because none of these routes have a match at all. So that's why we got pushed to the default static route, is because we don't have a match in the second octet, which is the shortest one that's available to us. And that one just doesn't work. Perfect. So it almost looks like the blue one would work, right? But then we've got to look at that 8 and compare it to the 0, and it doesn't work. Good job.